Greetings. So what we've got here is a 2001 Olds Bravada that the battery dies overnight, and I have confirmed that it is indeed from a parasitic amp draw. Now, many of you are familiar that one of my first videos that I've ever made was on parasitic amp draw and determining the circuit that is responsible. But now, later and more advanced, what I want to do with this video is look at some other methods for parasitic amp draw, better methods, because to be honest with you, the method that I showed in that video, which we'll briefly review in this video if you aren't familiar with parasitic amp draw, is the method shown in that video leaves a lot to be desired, and I actually do not use that method anymore. So let's go ahead and verify the parasitic amp draw using the original method so that we can both review that method and verify the amp draw. And then I'll show you some other methods that you can still do using a DVOM, but they're just much better methods and much faster and safer. But let's go ahead and review the old method of doing this test, which again, I no longer do. And if you are an advanced do-it-yourselfer and understand automotive electrical, I think you'll agree with me that there are many reasons why you want to abandon this procedure and start adapting some of the new ones that I'll show you. Okay, so on the old procedure, we're going to set up our DVOM to a 10 amp scale. Obviously, one of the main dangers right here, if you are doing advanced electrical diagnostics, just having your DVOM in this configuration and you forget you're in that configuration and later on you go and you do a voltage test or something with a PCM controlled component, you still have a 10 amp fuse that you're holding in your hand, even if you do a voltage reading, if you are in this configuration. So this is one of the main reasons I do not like this test in the first place. But we're going to go ahead and do this anyway. We cover a lot of this stuff on my other channel, by the way, with PCM testing. But I will tell you, you forget to reset your meter back to its volt configuration here, and you go ahead and do a voltage test on like a fuel injector or something like that, you will blow the PCM. So that is my primary reason I no longer use this method, actually. All right, the next step is to, of course, put the meter leads in series with the battery. So I'm going to do that by just disconnecting the negative battery cable. I prefer to do this with the negative battery cable, obviously, so I don't accidentally short the battery out. All right, another disadvantage, I guess, with this method, you force the vehicle owner to reset their stereo presets and all that, but they're probably used to doing that anyway if they've got a dead battery every morning. All right, let me just double check here that we've got our DVOM in screen. It looks like it is. I don't think there's any glare on there. I hope not. And obviously, I mean, just, basic electrical here. We're just going to go in series here. And let me connect this up. All right, now, once I connect this up, of course, it's not uncommon for the courtesy lights or whatever to turn on. We can see we've got 1.5 amps of draw right now, but this is obviously how we do our amp test. We're going to wait for any courtesy lights or whatever to turn off. All right, so we've given some time to this thing, easily a minute, and we can see that we are still well over 0.5 amp. What I would like to see is no more than 100 milliamps, probably less than 100 milliamps. We are well over that at almost 0.6 amps still. So we definitely have a confirmed parasitic amp draw on this vehicle. So the next step that we would do is I've got my meter nearby, and we just go ahead and pull off the fuse cover here. And we would also have to do this at the one inside the vehicle, of course. We'd probably go there first generally. And we just pull fuses one at a time until we watch our meter drop to a normal reading. Once we pull the fuse that drops the meter to the normal reading, there it is. We know the circuit that is causing the parasitic amp draw. All right, and I know that most of you guys are well familiar with this method, and if you are seeing this for the first time, I strongly suggest seeing my other video on it. I will put a link to it in the description. But for you guys that are more advanced, obviously you see the issue with doing the amp measurement as well. Another thing with this is it introduces some variables too. The act of disconnecting the battery and then reconnecting it again with your DVOM also presents a little bit of an issue because there may be some variable where you lose that parasitic amp draw after disconnecting the battery and it doesn't reappear with reconnecting. So all kinds of ways that this test leaves a little to be desired. For those those of you, by the way, that are subscribers on my other channel, Schrodinger's Box Quantum Mechanics, yes, this is the same 2001 Olds Bravada that we did all the other diagnostic stuff on. Transmission codes for the transmission shift solenoids that we did videos on. Also, this is the one that had the mystery coolant loss video that we're doing. So if you are not familiar with that other channel or haven't checked it out yet, that is a pay channel, but it costs less than a cup of coffee per month, and I have a 2-week free trial on it. I'll put a link right here or in the description. You can go check out videos for free, see if you think it's worth it. If you don't, nothing lost. So what we're going to do is I'm going to show you 2 methods. Both of them can use a DVOM. One of them you do just straight with your DVOM. It is actually how we will do the diagnosis, but I want to show you another one first using an inductive amp probe. And some of you guys are like, oh no, here goes the scope again. You don't need an oscilloscope to do an inductive amp probe measurement. An inductive amp probe works on your DVOM. And as a matter of fact, we'll go ahead and demonstrate that. But let me show you what we're going to do here. And the tool that we're going to use is a DC inductive amp clamp. And again, you don't need to buy a scope in order to get this to work. A DVOM will read this as well. And you can buy this at most auto repair stores or hardware stores or online or whatever. They're not all that expensive. Great tool to have. The way this works is you clamp this around a wire. In this case, we just simply clamp it around a battery cable without having to disconnect it or anything. And the idea is that when electricity moves through a wire, it generates a magnetic field. This basically detects and measures the amount of magnetic field. The more amperage through a wire, then the higher the magnetic field will be, the more that this will detect that. And it basically puts out a voltage signal so that you can read it on DVOM. So you're not really reading amperage with your DVOM or your scope. You're actually reading voltage that this tool produces that is proportionate to the amperage that it is detecting. So let's go ahead and set this up and I'll show you how it works. You just hook up the tool to your DVOM as if you're just going to do a regular voltage test as always. And then turn your probe on. I'm going to go ahead and set it to the 20 amp setting and 0 it. And then just go ahead and loop it around the cable that you are testing. So I'm just going to go ahead and loop around the negative battery cable in this case. And I've got my meter set on a 20 volt scale, and you can see that we're reading 0.05, not 0.5, but remember we're measuring volts, not amps. We need to multiply this result by 10 to get the number of amps. And when we do that, we would see we would have 0.5 amps. We can also put this onto my scope and get a more accurate measurement. But just using this tool in your DVOM, again, the same principle. We just go to the fuse box, pluck out fuses one at a time until we see this go to 0, basically. And using my scope, it just does the math for you automatically if you go ahead and set it to the amp scale. And we can see we're probably losing a little bit of battery juice here, but we are indeed at 0.5 amps. And again, through this whole time, we've still maintained that draw. So again, we have a confirmed sustained parasitic amp draw for sure. So as you can see, this is a much easier and faster way of doing it, but mostly I like it because it's a lot safer. Since getting this probe, I no longer actually use my DVOM for amp measurements, which is plenty fine with me because I do a lot more of the electrical testing with PCM involved components, so I do not like having this thing ever set to amp detection by accident. But even with the amp probe, we still have the kind of time-consuming, laborious issue of pulling fuses one at a time until we finally drop the amperage and confirm the circuit that is causing the amp draw. So I will actually show you a better way, and I actually can't take credit for this. It is actually a viewer from over a year ago that brought this up on the original video, as a matter of fact. This method that I now use for doing this type of testing was actually introduced to me well over a year ago by viewer Arlen Roche. Other viewers brought it up as well, but Arlen was by far the first to do it. And this method basically takes advantage of voltage drop. Now, I'll have to leave it up to you, if you're not familiar with the concept of voltage drop, to click the link in the description so that you can see my video on voltage drop so you understand what we're doing. Actually, even if you don't do that, you can still do this test and just look at the numbers, but we severely discourage such practice on this channel. We like to understand what we are doing so that we just don't become brainless monkeys just following instructions. We can sort of design our own tests based on our understanding of concepts. But basically what we're going to do is it should be very obvious if you understand voltage drop that while of course there will be voltage, most likely all these fuses are going to be on the positive side of the circuit. While there will be voltage there will not be current through most of these fuses. If there is no current, obviously we cannot have voltage drop. If any of these fuses actually have current going through them, then there will be some voltage drop, even a minimal amount through the fuse. And we're just going to do a voltage drop measurement to detect that. Now, one of the things is that we're going to have a very minimal amount of voltage drop, so we are going to need to set into a millivolt scale. If you do not have millivolt detection with your DVOM, then probably this test is not going to work. And all we have to do is test the contact points on the fuse and see if we have any voltage drop. Now, just as a positive control, what I'm going to do, we're going to go ahead and turn on the headlights on this car and then look for voltage drop on the headlight fuse. All right, what I've done now is I've turned on the headlamps. You can probably hear the warning chime in the background. So let's go ahead and look at one fuse here that will not have current through it. And we see there is no voltage drop. This is actually a turn signal fuse. Now let me go ahead and connect up to the headlamp and watch what happens. And you can see we measure at least an order of magnitude, confirming that there must be current through here. Let's go ahead and go back to this fuse. And you see there's a little wavering on the meter, but that is clearly, obviously, just some background there. But when we go to a fuse that absolutely definitely has current through it, you see we measure an order of magnitude that is a confirmed voltage drop confirmation. There is current through that fuse. Then what we can do is reconfigure our DVOM to the 10 amp mode, and we can go ahead and just pull that fuse and do an actual direct amperage test on that circuit. And we can see that this is drawing 3 amps on that circuit. Now, some of you, of course, are probably saying, well, I'm doing amp detection using the meter, and I just kind of went off on how I don't like doing that. But actually, the way that I do this is I don't actually measure the amperage at the fuse port using the meter. All I do is I just simply have another meter or my scope hooked up with my low amp probe, and all I do is look at the low amp probe and confirm when I pull a fuse that I get a positive test on this method. I pull the fuse, watch that my low amp probe shows that the circuit drops altogether. So by doing that method, I still never have to take my meter out of voltage mode. So as you can see, that is a much, much more efficient method of determining the suspected circuits without pulling each fuse one at a time. You can just narrow on the circuits that are potentially of interest. This is especially helpful if you're looking at fuses inside the passenger compartment, under the dashboard, where it's really awkward. This sure beats pulling the fuses one at a time while you're laying on your back or whatever. So I want to really thank Arlen for that advice, and also to everybody else who provided that advice. It's just another example how the comments on this channel are sometimes more useful than the videos, because that is another example of a comment that changed the way that I do things for the better, and this is absolutely my method of choice. But that said, what we're going to do is, again, you can do this with a single DVOM. You just have to switch back to your amp detection mode through that method. I'm going to go ahead and determine which circuit is responsible for this voltage drop using the method that I do, using 2 DVOMs and my low amp probe, and we'll see which circuit is responsible. Now, one of the things I did notice about this car is it has an aftermarket stereo system. One of the things that I've certainly experienced is about 80% of the time the improper installation of an accessory like a stereo system, hardwired radar detector, or something like that, that 80% of the time I find that that is the fault with a parasitic amp draw. So we're going to go ahead and check that out first. All right, so let's check this thing out. Let's go ahead and... yeah, because there's nothing that I think is better for a driver than to be distracted by a DVD player on the dashboard. But one thing that I've noticed in trying to play around with this thing a little bit, not sure if you notice anything unusual here. I certainly do. But apparently this vehicle must be owned by pop artist Meghan Trainor, because They are all about that bass, no treble. All right, so I've set up my low amp probe onto a scope, but of course this is just the same thing as you would do if you were using your DVOM, so don't be thrown off by the scope. I'm only using the scope because of the large screen output so that you can see it easy on the camera. And since I am suspecting this stereo system is the most likely cause for this high amperage draw, we're just going to go ahead and pull the radio fuse. And that is going to be this guy right here. So when I pull this fuse, let's see if our amps drop. And of course, check it out, they do. And when I reinstall it, we see the amperage. So we know that the radio circuit is without question responsible for that amp draw. Now, here's the mistake a lot of people are going to make about that. What often I see is that pulling this fuse does not change the amperage draw. And the reason is because the people did not wire it through the radio circuit. So just because you pull that fuse and you don't see the amperage draw, that doesn't mean you can rule out the radio. Usually it's just the opposite. But obviously we have a problem with this aftermarket system on the correct circuit that it's wired to. So this is just going to take some hunting and detective work, which I don't think I'm going to go ahead and video just because I've got a lot of time constraints. I've got a lot of other things I got to fix on this vehicle this weekend. But the bottom line is this is how we diagnose there is a confirmed problem with this circuit. And just to show you the single DVOM method on a confirmed actual case study for voltage drop, we can go along testing our fuses, but we don't have any significant activity on any of them. But then once I go to the radio fuse, you're going to see a considerable, we can see that there is a significant voltage drop that we're measuring there. So obviously that is going to be a circuit that we are interested in. We would then go ahead and remove that fuse, reconfigure our DVOM. So we're now in the 10 amp scale, and we would go ahead, take a direct amperage measurement in that circuit, and we can see that we've got a high amperage draw. All right, well, there you have it, a much, much better set of methods for doing parasitic amp draw for the advanced do-it-yourselfer so that you can determine the circuit that's causing the draw much more efficiently and much safer. If you like stuff like this, or if you were having trouble following along the basic electrical stuff and the DVOM settings, we do a lot more of that kind of tutorial stuff in an easy-to-follow style on my other channel, Schrodinger's Box Quantum Mechanics, so feel free to check out the link here or in the description to go over there. It is free to just check out the videos there. If they aren't what you're looking for, nothing lost on your part. So thanks for watching. I hope you found this helpful. We'll see you next time.